Alright, Chapter 1, Introduction to 3D Design. Welcome to the fantastic world of 3D AutoCAD with excellent software for creating 3D projects, all technical errors, but instead of 2D representation, it's much better if we could create an accurate 3D model, view them all perspective, even from the inside, get the 2D drawing easily AutoCAD, but we can. The topics covered in the chapter as follows. Importance of a third coordinate, choosing the managing a 3D workspace, why object properties fundamental in 3D, auxiliary OSNAP, OSNAP, Ortho, and others can ease the work of 3D, 2D commands in 3D world, how to use linear 3D commands, how to create a greater 3D model. Alright, the Z coordinate. 3D is all about the third Z coordinate. In 2D, we only care about the XY axis, but never use the Z axis. Most of the time, we don't even use these coordinates, just the top 20 AutoCAD commands, Ortho tool, and so on. But 3D in 3D, the correct use of the coordinates substantially accelerates your work. We will first briefly cover how to introduce the points of coordinates, how to extrapolate the third dimension. Alright, shows a floor plan extracted. Absolute coordinates. Location all any of the AutoCAD related with the coordinate system. Any of the coordinate system characterized with the original positive the direction for X and Y areas. The Z axis is obtained directly by the X and Y axis of the right hand rule. If you rotate the right hand of the axis to the Y axis, the thumb indicates the positive Z direction. Picturing when prompting for a point, besides specifying the drawing area with a pointed device such as the mouse, we enter the coordinates using the keyboard. The format absolute Cartesian coordinates related with the origin defined with the values of three orthogonal coordinates, namely x, y, and z, separated by the common x coordinate, y coordinate, z coordinate. Z coordinate can be omitted. For instance, we define a point with the absolute coordinates of 30, 20, and 10. This means that the absolute 30 is in the x direction, 20 is in the y direction, 10 is in the z direction. Relative coordinates. Frequently, we can specify the point over the coordinates, but one of it's related with the previous point, but the format relative to the Cartesian coordinate is defined with a symbol AT or at symbol, followed by the increment values of three-dimensional directions separated by commas. At x increment, x, y, and z increment. Of course, one of the more increments can be zero. Z increment can be omitted. For instance, to define the point relative to the coordinates 8, 0 to 20, 10, this means it relation point is 0x, 20, y, and 10 in the z in the direction. 10 is in the z direction. Point filters. When we want to specify the point, it decomposes step by step with the separator for the coordinates based on the different locations where you use the filters prompting for the point. We access the filters digitizing x, y, and axes. Z-axis for the individual coordinates are x, y, y, z, and zx for pair coordinates. Another way is using the OSNAP control plus right click, then pointer filters. So control plus right click and then going to pointer filters. AutoCAD requests the remaining coordinates until the completion of the point definition. Imagine you want to see it specify a point, for instance, center circle with its x coordinate is given the midpoint edge, and the y coordinate is in the midpoint with another edge, and finally z coordinate is at any point with the top surface, assuming that the midpoint OSNAP predefined dialog should read. Command specify a center point at x of the midpoint edge, y at the midpoint edge, any point over the top surface, specify radius circle value. Then we have this neat little circle here. Workspaces. AutoCAD comes with a shuffle of workspaces upon each of the choose the workspace for the classic environmental, where the ribbon and change of the workspace we can pick for the workspace switch button status bar. As you can see, the settings are set for the AutoCAD Classical. There are other processes for exceeding the commands such as the workspace list down on the quick access toolbar or the title bar of the workspace toolbar with the digitizing WS current and by the access showing with the consistent among all versions and always available classic environment. Classic environment is made for the toolbar for the menu bar to design. Even the ribbon, the AutoCAD comes with the AutoCAD Classic workspace, but is very simple to adapt and view with the suitable tools for 3D. Advantages for the environmental speed, consistency, show with another toolbar, right click over any toolbar, choose it, and then typically we want to have the following toolbars visually beside the standard layers, layers 2, modeling, solid editing, and rendering. Show the ribbon environment. Since 2009, the AutoCAD also allowed the ribbon-based environment and normally environmental use with neither toolbars or menu bar. The AutoCAD comes with a two-ribbon workspace, namely the 3D Basic and 3D Modeling, first being less useful than the second. The advantages that we have consistently with the software and the command divided into the panel tabs. The ribbon can be collapsed in a single line that includes some of the command but not available for the toolbars. Disadvantage is that the dynamic environment, and we frequently have to active other panels to access the commands. Some of the import commands and functions are not always visible. And it shows more ribbons. And when modeling in 3D layers, visibility also almost all mandatory may be added with the quick access toolbars and playing with the cut CUI command or right clicking above the command icon you want to add. Another way to pull the layers panel is drawing area to make it permanently visible. Layers, transparency, and other properties. When we have the modeling AutoCAD with the ability with the control of the object property essential for the sum of the hours spent on the new 3D model with the command have with hundreds of objects with the overlap with the descriptive of the model visibility here with the most important property layers. Current layers application fundamental with the 2D and 3D assumes extreme importance. Each type of 3D object should be with a proper layer in a proper layer, thus using the control of the name properties. Name a good piece of the device is not to mix 2D objects with 3D objects, same layers. So the 3D objects must be easily identified, for instance, by adding a 3D prefix. Freezing and thawing. In 3D density of the screen, the information can get huge. Some of the freezing and unfreezing of the layers of the permanently processed with the better freeze of the layers, then turn off because of the object with the frozen layers are not processed. For instance, the regenerating, the counting the zoom, counting the zoom extents for the accelerating of the 3D process, lock and unlock. It's quite annoying to notice for the advantage of the phase of the project walls move with the cause of the several area with the needs of the information visible. The best way to avoid these areas is to lock the layers. Color. A good logical color palette is assigned with the other layers and can improve our understanding of the modeling transparency of the way you want to see through walls other object creating process that may be given the value of 0 to 90% of the layer's transparency layer. Last but not least, the best of the easiest process is assigning renting a material of the objects by layer with another good point is to apply with the correct and detailed layer scheme. Transparency is a property of the layers over the objects have been available since the version 2011. Besides utility of the layers, can also be applied with directly to the object. For instances, may have called the 3D slab. Just want to see through the upper slab, we change the objects, transparency of the property, or control +1 to see the transparency of the drawing area with the TPY button on this, or transparency is used in the TPY on the command ribbon and status bar must be on. Visibility. Another recent improvement in AutoCAD's ability with the hide, isolate objects with the changing layer properties. Select the opposite of the hide, isolate all objects subject to the hidden, and right click on them. On the cursor menu, choose isolate, and then isolate objects. All objects not selected with the invisible using the isolating object command. Hide objects. The selected objects invisible using the hide objects and isolate. And object isolation. All objects are turned on using isolate objects command. There's a small lamp icon in the status of the bar. The second icon from the right. This lamp is red, means that there are hidden objects, and if it is yellow, all objects are visible. Shown on the following image, application transparency, hide objects, the left wall on the upper slab. Alright, auxiliary tools. AutoCAD software were very precise with the correct application for these auxiliary tools. With the key fact for the good objects, all users should be familiar with the less over the ortho and OSNAP tools with the following application for the auxiliary tool. The 3D project complemented with the first exercise, OSNAP, ortho, Polar, and O-Track auxiliary tools. Let's start with the object snapping, preferably with the most frequently used tool with the precision. Every time in the Autocad prompt with the point, we can ask predetermined object snaps, also known as O-snaps. O-snap buttons if the status bar is on. Change it if we only want to click the O-snap button, and then press F3. With it. If you want the individual O-snap, then we can make any among other ways to digitize 3 letters, for instance, MID for midpoint, O-snap with control right click, or use the O-snap menu, click and control right click. O-snaps work everywhere in the 3D, which is great with a special use over the extrusion O-snap mode, which allows you to specify the point with the distance, the direction, and any edge. But if we want to specify the projection of 3D points onto with a working XY plane, easy O-snap Z variable is set to 1. Also specify points or project onto the plane. The variable is not saved. The ODAD is assigned an initial value. Alright, so there's your endpoint, and the great news of the Ortho F8 key and Polar F10 key work in 3D. That is when we can specify points directing the cursor along the z-axis, assigning distance lots of the relative of the absolute relative of the at sign spared no. Alright, your O-track or F11 U with the derived points are predefined. O-snap, though, also working along with the Z direction, which may pass over the O-snap, creating a distance along with each specific direction, just obtaining crossing. 3D O-snaps tooling. Starting with the version 2.11, the AutoCAD allow with you specify 3D object snaps. Also can here with the access to predefine the 3D O-snap, F4, where we can access individually with the O-snap vertices, midpoints of the edges, centers, faces, knots, spline points. Points are perpendicular to the face and points nearest to the face. Exercise 1. Using the line command, coordinate with the auxiliary tools, latest grade with the cabinet, select skeleton. All dimensions in meters. We start with the lower left-hand corner of the Ortho and Polar button. Must be on the O-track and the O-snap buttons with the endpoint and midpoint predefined. Note, as in the T2, rotating of the wheel of the mouse forward, zoom in, rotating of the wheel with the backward, zoom out. All related to cursor positions automatically orbit around the model when holding shift. Down shift wheel simultaneously with the cursor for the chain of the 2 small ellipses. This will drag the mouse's orbit around the model. Visualization subject for the next chapter. Alright, this show's been running a line of command with a block direction of the exit, Polar or Ortho, and assigning with the distances. Command line, first point, any point. Specify the next distance is 0.6. With the V block direction, assign the distance. Specify the next point is 0.7. The best way to specify the point with the relative conditions. Coordinates specify the points at 0.3, 0, and 0.4. We block the Z direction, assign the distance, specify the nodes. Next point is 0.7. The best way to close the left polygon is to pause for the first point and move the cursor up the find the crossing of the ortho command with the last point, with apply with the close option, close with the polygon. Specify the next point, and then close or undo point with the O-track. Specify the next point. C for close. We copy all the lines 1 meter in Y direction. Command copy. Select option. Specify option. Opposite corner 6. Select option. Enter with the current settings. Copy mode multiple. Specify the base point with the displacement mode. Displacement point. Specify second point array using first point as displacement 1. Specified second point array. Exit. Undo. Exit and enter. We complete the cabinet skeleton drawing lines between the endpoints and the midpoints of the command line. Application 2D command. Can those everyday commands be used in the 3D? Of course, if they can. We have already seen with the line command layer with the other properties. Let's see some of the particularly with the 3D application. Learning a whole bunch of the known commands can also be applied with the drawing command. Basically, all drawing commands can be used with the 3D provided with we have with the current correct working plane line being exception. Line command can have endpoints anywhere, so the real 3D command, but the circle arcs and polygons include polygons Rectangles are drawn on the working plane called active coordinate plane with a plane parallel to the working plane. Edit commands. Here's a list of most important editing commands that work in some way with a 2D or 3D. Erase, move, copy, scale, join, explode, and break. Some of the commands work only with the object's plane, but is not necessarily active working plane. Examples of the fillet and chamfer and the offset. There also are some of the working only relation to active working plane, such as mirror, array, classic, and array before version 2012. Rotate, and next to editing commands have special 3D features. Trim and extend, both commands have the option project with the special with a linear object for the cut and with the extend with the bounds for the relieve with the current with the coordinating a system with the current view with the allow with the cutting and extending object. That the current view seems to be on the same plane, but they are really on the different planes. Array with the command change with a lot of the version 2012. Now we have the three different commands: the rectangular polar path arrays. Among the multiple options, there are two special importance for 3D rows, where we can have the define the number of the rows, height, distance, levels, also with a variation in height. Okay, other it needs a command. Now that one can be Autocad with acquiring information time 2, the distance command, DIST, or distance command allows you to obtain 3D distance increments X, Y, and Z with the direction between 2 points. Another important command is the ID or other tools menu bar inquiry ID point for inquiring absolute coordinates of the point. Blocks work exactly in the same way the 2D and 3D. When inserting a block with a uniform scale, we can specify the different scale in Z direction and region of the 2D opaque closed object with the frequent use of the 3D base for the 3D, but they can use the very useful extraction areas and area movements and the other generic properties. To create regions, we must have the contours already drawn. Contours can be lines with arc and clips, arcs, circles, ellipses, elliptical arcs, and splines. And 2D regions are created with the two commands. The region command, also known as the alias REG, creates a region with a closed object with a set of the linear object with a defined closed boundary, with the only prompts from the selection object with the original objects by default are deleted. Boundary. The great command alias BO allows the easy creation of the closed polyline region. Polylines or other regions specifying the internal points, closed boundaries. An example follows. Alright, exercise 1-2. We're going to create a 2D object from the source of the sum of the regions. So start AutoCAD, create the 2D linear object similar to those shown in the following image. The following new dimensions are not important. Create a new layer regions as of a different color to activate it into the run the boundary command or the BO alias along with the dialog box showing the object type. List shows regions, specify that the pick points in between when the dialog box disappears. Specify that the 4 points inside of the closed area shown with the image brush to the enter of the 4 regions are created. The freeze layer 0 with the view of the only regions. Regions are opaque and check with the apply with the VS current command that explained in the next chapter. Achieve the realistic option. 6. Apply with the VS current command with again achieve the 2D wireframe option for the comeback to the normal. We do not need to save this drawing. Alright, linear 3D entities. We can apply the thickness to the most of the linear 2D entity, but they also create the linear 3D entity with the like of the 3D polylines and splines. Thickness. Almost all linear entities will, we know of the 2D properly called with the thickness, whose the value represented the height of the along the z-axis. A better word actually should be height. And this is only 3D feature allowed with the AutoCAD Lite and can be applied with the text and made with the text style with using SHX font. Beyond it is quite limited. The best way to change the value of the thickness is the property command Control +1. Line is still a line. A text still a text, but the proper visualization of these entities can transmit a 3D feeling. It shows some 3D text. 3D polylines. Polylines created with the P line come in with a 2D with an L line with a vertex with different X, Z coordinates. With the polylines are designed lightweight polylines, but the single object with needed to be composed of the segments of the endpoints with the different Z coordinates for the answer with to create with 3D polylines. The process is available. The 3D POLY command. This command is alias 3P, created with 3D polylines from the start that works with the like of the line command. but results in a single object. The join command created with the alias J creates a 3D polyline from the contiguous sequencing of lines shared endpoints over the end of the one point of the line to the outplane of the 3D plane to create it. Repeat edit, the same as also alias PE in the command prompt used for the creation of the 2D polylines from line arc. You can also have the join lines of a 3D polyline. First of the object must also already be a 3D polyline. Note, starting with the version 2012, the best way to apply the join command is to select all line segment of the first command in the prompt and without specifying a source of the object. Depending on the type of the selected object, their position, the most suitable object is automatically created. In which situation may we have all utility of a 3D polyline? 3D polylines particularly useful for the measure objects that develop in different directions, such as piping, wiring, to find paths to the other 3D objects, such as the pipe the creation of 3D post solids and surfaces with a linear object subject of Chapter 4, creating solid surfaces from 2D. Alright, splines and helixes. The spline and helix is smooth and linear objects normally without corners of the path of the root with near specified point. The spline with spline is short for a non-uniform rational B-spline or NURBS, non-uniform rational B-spline. NURBS, non-uniform rational B-spline, NURBS. Splines are described with the shape of the parametric mathematical equation. Have no fear of the Autocad. Will internally deal with this and we will not have to. Splines are used whenever we need smooth curves also with the foundation for non-uniform rational B-spline surfaces that must be the surface of the automotive and aeronautical projects. To create a spline, we apply with the spline command, alias SPL. Default with the command only prompt with the location of the fit points and the spline passes through with the specified points. The enter finishes the spline and the close option creates a closed spline. We can control the splines by two sets of vertices. To fit points, they are points for the used to create the spline and control vertices. These are points defined in the spline. When selected with a small blue triangle, that allows you switching between the fit points and the control vertices with the edit of the simple edit. The spline is very simple with this very select without the command with the work with the grips. Either the clip of the grip or the move that we can play for the cursor over the grip of the grip menu. Choose for the move of the vertices. Add one or remove the vertices. The last process known as the multiple function grip. I show what fit points are, and then control vertices, and then multiple function grip, which comes with a stretch point, add fit, and remove fit point. Note the Autocad 2012 join command also a great tool for the creation of the complex spline that we may have to continue the non-planar sequence of the line, the arc elliptical ARB splines with the result of a single spline. The helix command we can create with a 2D, 3D hex, a spiral with the default with the command prompt with the center point with the base rate, with the top rate, with the height, with the option with the we have the position, axis endpoint with the number of turns with the height of the one complete turn, and the twist of the helix drum with the clockwise over the counterclockwise direction. That at helix options we can use the grip of the properties command. So it shows the helix command, and then the number of turns, turn height, base rate, top rate, twist, turn slope, stalling, X, Y, and Z constraints and height. If we explode the helix, the result is a spline. The plane command new in version 2012 creates a special spline with a connect for the two open linear object of the command. Only prime with the selection, first curve with the selection of. Second curve sections must be near the endpoints of the connect with the continuity option. Allow with the choice for the apply with the continuity tangent. With the tangent continuity known as the G1, continue with the smooth with the curvature continuity known as G2. Alright, how to create great 3D models. Here are several possibilities with starting with a 3D project. We created the 3D project from a complete set of the 2D drawings with all the necessary viewpoints included. We do not have the project idealized. We just have to decide the best approach for the commands that are used. Create the 3D project with the plant view with some of the other elements. Here, where they have the project of the lab, will probably have to study with several proper possibilities. But in order to find the most suitable project with the create with the 3D project from scratch, we now have some of the conditions about space and functionality. Others for any of the other possibilities. The keyword is planning. First, we have the careful planning of the work instead of immediately starting with the model, but it's better with the least time consuming to decide the drafting sequence and text. task. Some of the important questions in this phase: whether you have access to something similar, have that complex from the will bring my project. How do I have some 3D blocks that I maybe use? Have I created needed layers other than definition, layout, styles, and other so on? Any other project? Am I going on the external references in the project? Do I have all the necessary information? If we have the 2D drawings, then these must be carefully studied, especially if they are any of the inconsistent between the views and how to start. Next, we set up the model. We can open the most important 2D drawing, say with a different name. We can start with the drawing, insert with the other drawings as a block for the external reference, and verify if its units coherent with applying the units command. Continuing setup of the creator and create layers and other definitions of the winning command. Here is the Add Center. It also names the Design Center Control plus 2. This allows you to gathering all layers of the block for the other definition of the drawing without opening them. If we pretend some of the nice realistic image of the rendering, must be careful with the layers, knowing that the easiest way to design the materials is by layer. Should we start with the floor plan's elevation with the dependent of the project with the kit model from the plane of the trim of the parts may come from other views, or they may be positioned final piece of the device with the keep sample version of your project for the important steps is achieved with the reset must save with the backup to be changed with our mind about the step of the if the current with the corrupted will minimize the loss. Summary. In this chapter, we introduce the 3D with the importance of the third coordinate, with the inch of the points absolute, and the relative of the coordinates for the application of the point filter, the analyze workspace, and how to control the AutoCAD environment, the important layer of the transparency, the other properties of the where, then in explaining with the auxiliary tools the coverage before we looked at how to use them and leave the 3D project when solved the application of the command of the 3D use daily with some of the particular importance, such as the boundary. We also cover the linear 3D command with the thickness property with the chapter with the covering good practice with the modeling in 3D. Alright, Chapter 2, Visualizing 3D Models.